Today we're going to discuss the 6 trigonometric functions. Typically in geometry, you pretty much only dealt with the sine, the cosine, and the tangent. You might have come across the cosecant, secant, and cotangent last year, but if not, so be it. We'll talk about it today. So I want to refresh this picture a little bit. First thing we want to notice is that we have a right triangle. And when we use right triangles, that's the only time we can use our sine, cosine, and tangent ratios. These ratios will not work for any other triangle other than a right triangle. Now, a little inaccuracy here. Sides are typically labeled with lowercase letters, and the angles opposite them have the corresponding capital letter. So this side we'll call small case a, this angle capital. This will be a small case c, and this is a capital C. Notice always opposite the right angle is your hypotenuse. This angle theta is this little notation right here. In referencing theta, the side B is actually opposite that because it's directly across. The side next to or containing that angle's ray is the adjacent side. Sine, cosine, and tangent you covered once again in geometry and probably last year in Algebra 2. We know the sine ratio is the opposite over the hypotenuse. The adjacent over the hypotenuse is the cosine ratio, and the opposite over the adjacent is the tangent ratio. Now, if we look at the cosecant, of an angle is basically the reciprocal of the sine, and we can see that right here. The secant of the angle is the reciprocal of the cosine, so it's the hypotenuse over the adjacent. And the cotangent is just the reciprocal of the tangent. So it's the adjacent over the opposite instead of the opposite over the adjacent. And we will use all these throughout the day. So let's start by finding some ratios. I'm given a triangle in which the hypotenuse of that triangle is 13, and I have some angle A and its opposite side, and I'm asked to find the cosine of the angle A. Now the cosine of an angle is the adjacent over the hypotenuse. Now in this case, we don't have the adjacent, we have the opposite relative to the angle. So I need to find that adjacent side. I'm going to need to find side B. So in this case, I want to take and use my Pythagorean theorem. I have 13 squared equals 5 squared plus the adjacent side squared. This is 169 minus 25, which is what, 144, and that's equal to the adjacent side squared. So my adjacent in this case is equal to 12. Therefore, if I need my adjacent over my hypotenuse for my cosine ratio, I just plug in 12 over 13. And that's my cosine ratio. Now, in the next case, I'm given a right triangle once again where I have a hypotenuse of 7. I'm given a side of 3, and I'm referenced to angle B now. So I need to know the relationship of this side to this angle. Well, this side, once again, is my adjacent side. So this side across from B is my opposite side. I need the cosecant, which is the reciprocal of sine. So if sine is the opposite over the hypotenuse, then I'm looking for a hypotenuse value over an opposite side. I have my hypotenuse of 7, and I just need the opposite side. So once again, I'm going to go to my Pythagorean theorem. I have 7 squared equals 3 squared plus the opposite side squared. 49 minus 9 is equal to my opposite side squared. So the square root of 40, or 2 root 10, is going to equal my opposite side. Plugging into my cosecant ratio, I have 7 over 2 root 10, which isn't going to be good enough to leave. I'm going to have to rationalize by root 10 over root 10, giving me 7 root 10 over 20, which is equal to the cosecant of angle B. All right, these next set of problems are a little bit easier. We're given a cosine of a value and asked for its secant. We know that the cosine and the secant are reciprocals. So really all we have to do is take the reciprocal of the ratio and we'll have secant. So 9/4 is going to be our secant ratio of that angle theta. We don't even need a triangle to do this. Likewise, my cosecant is root 7 over 2, and I'm asked to find my sine. Well, I know that if cosecant is the reciprocal of sine, then sine must be the reciprocal of cosecant. So once again, I just take the reciprocal, get 2 over root 7, and I have the sine value, but that's not going to be good enough once again. So we're going to rationalize by root 7 over root 7 and get 2 root 7 over 7 for my sine value. Okay, special right triangles. We saw these back in geometry. We know that the short side is always opposite my 30-degree angle, and the long side is always opposite my 60-degree angle. Opposite by 90 degrees is always your hypotenuse. So we also had, I guess you call it a formula in geometry, that said the short side is half the hypotenuse. Hopefully you remember that one. And we know the long side is equal to the short side times root 3. When I'm talking about an isosceles right triangle, I'm talking about a 45, 45, 90. And in that 45, 45, 90, I know my hypotenuse is equal to a side times root 2. And we know since I have an isosceles triangle, the two sides are the same. We're going to use these formulas in our next couple examples. So what I have for you here is I have a 30, 60, 90 right triangle. And what I'd like you to do is pick a number for the short side independently of what I'm going to write. So write a number down for yourself right now. I'm going to choose a number 8. You've chosen whatever you want. And we're going to go through and calculate the sine of 30, the cosine of 30, the tangent of 30, the sine of 60, the cosine of 60, and the tangent of 60. But in order to calculate these ratios, we're going to need to find our missing sides. So I know the short side is equal to half the hypotenuse, which means the hypotenuse must be double that, or 16. If and the long side is equal to the short side times root 3. So now that I have these values, I'm going to find my ratios. I'm going to find the sine of 30, cosine of 30, and the tangent of 30. So sine of 30 is equal to the opposite over the hypotenuse. The opposite is 8. Hypotenuse is 16, which reduces to a half. And if you've done your calculation, my guess is you got a half as well. Cosine is equal to the adjacent over the hypotenuse. So that's 8 root 3 over 16, which is equal to root 3 over 2. And once again, my bet is you got that as well, no matter what side you picked for the short side. Tangent is equal to the opposite, is 8, over the adjacent, which is 8 root 3. Can't have a radical in the denominator, so I'm going to rationalize by root 3 over root 3. Notice my 8s will go, and I'm left with root 3 over 3. And I'd bet money that you got those same values regardless of what side you picked over here. That's pretty significant. Now I'll find the sine of 60, the cosine of 60, and the tangent of 60. So sine of 60, I take a look at my 60, it's equal to the opposite over the hypotenuse. So that's 8 root 3 over 16, which is root 3 over 2. Cosine of 60 is the adjacent, which is 8 in this case, over the hypotenuse of 16. It's a half. And the tangent of 60 is the opposite, which is 8 root 3, over the adjacent of 8, thus root 3. And once again, I would bet you got those three numbers regardless of what number you picked on this side. If you didn't get those three numbers, you probably made a calculation error. Let's move on. I'd like to do the same thing with the 45, 45, 90. So again, you pick any value for a leg of this. Not the hypotenuse, but a leg. I'm going to pick, let's say, 5. So I know this is 5 as well, and I know this is 5 root 2. I'm going to find the sine of 45, the cosine of 45, and the tangent of 45. And it doesn't matter which 45 we use. So, taking the sine of 45, that's the opposite over the hypotenuse. Opposite 5, hypotenuse 5 root 2, rationalize by root 2 over root 2, end up with 5 root 2, actually the 5's reduced, so I end up with root 2 over 2. Let's take the cosine of 45. Let's use this 45, so that's the adjacent over the hypotenuse. What do you know? Got that same ratio, 5 over 5 root 2. If I were to rationalize, I get the same answer as my sine. Again, kind of significant. Lastly, we're going to take and find the tangent of 45, which is the opposite over the adjacent, which gives us 5 over 5, or 1. Regardless of what number you picked for the side or the leg of this 45, 45, my bet is that you got these three values for the sine, cosine, and tangent. Again, this is a significant concept. What I'm going to need you to do is know these ratios extremely well within the next day or two. These ratios work for any triangle of any length, as long as they're 30, 60, 90 triangles or 45, 45, 90 triangles. Super significant concept. Here are the questions to answer for the day. We'll see you tomorrow.